So we got to this point here yesterday where we drew our various renditions of the benzene ring. And again, I don't care which way you draw it. The simplest way is to just draw this hexagonal structure to represent each of the carbons and individual hydrogens, and then a circle on the inside to represent those double bonds kind of spread over the entire structure. Again, it's got the alternating double bonds, and it's got a contributing structure because it has resonance where the double bonds can be in the other location. Okay, naming them. I don't have a handout for this. You can write this down, naming simple aromatic compounds. Just put see page 21 of text for the summary. Let's not worry about the two bullets because I'm going to go over them. I'm going to talk about the simple aromatic compounds first, and then I'll talk about how you can treat the benzene as a branch. All right. So just write the summary and see the textbook. Once I tell you how to do it, it's really very straightforward, and I don't think we need to write down in great detail. So the first example I'm going to do is where we're going to have the benzene ring as the main part of the molecule. So in other words, it's like a cyclic hydrocarbon where we're going to have then branches off of the carbons off of the ring, right? The second method is where we've got a big long chain and then we've got a benzene ring kind of as a branch. So it depends on how you look at the situation. Okay, so let's take a look at the simple guys. What did you write down? Did you write down see page 21 text summary? Because there's no need to write those two bullets. Really straightforward business. That's all right. It's either the main part or it's a branch. It's pretty straightforward. So number one, here we have it as branches. Branches off of the main part of the benzene ring. So this, you can see here we've got a little CH3 off to the side, and we've got the main benzene ring. And so it's not like we're dealing with a big chain that has a benzene ring off of it. So this is simply going to be called methyl, right? Because again, this is our methyl group, and it's stuck to a benzene. So this is simply called methylbenzene. Because we have the benzene ring as the main structure, it gets our base name, benzene, and then we put a branch on it. No need for a number because there's only one, and you just stick it on there and you're going to get the picture right if you have to draw it. Now for the second one, we've got two methyls that are right beside each other. Now let me just explain to you the concept I'm going to teach you at this point. If I have two branches, they can either be beside each other or they can be separated by one space, or they can be on opposite sides of each other. Those are the only three options if you have two branches. So in naming this, there's actually two naming styles. We could call this position 1. So we could say this is position 1 and this is position 2. And so we could call this 1, 2. In this case, I have two methyls, dimethyl, and it's stuck to the main object there, the benzene. Benzene. Okay? Now, oh, just one second. I think so. I think we got a little bit of yeah. No. The other way in which we name this, when they're together beside each other, the prefix that chemists have used is ortho. They let that ortho prefix represent the fact that they're together. So this is sometimes called ortho, that's an H, ortho dimethylbenzene. Ortho dimethylbenzene. Yeah, it's a tongue twister. Another way to represent that is treating the O like a number, O-dimethylbenzene. And I remember that ortho means together because I think of the orthodontist, and his job is to bring your teeth together if you have teeth that are apart. Does that make sense? Yes? No? You want an orthodontist to bring your teeth together. I think that's what it means. I'm not sure. That's the way I think of it anyway, right? Ortho means together. It means that they're close together. Okay, let's take a look at the next situation. Here they're separated by 1. We could number these again, 1, 2, 3, and there would be nothing wrong with using a numbering system, 1, 3, dimethylbenzene. The prefix they use to represent the one that isn't opposite or together, but in between or in the middle, is meta. And again, I use meta, starting with an M, means middle. That's the way I remember it, meta. So this is meta dimethylbenzene. Oops, dropped the Z. Zine. Meta-dimethylbenzene, or M-dimethylbenzene. Okay? All right? So orthos together, meta is middle, and the opposite positions we say are the para positions. I don't know, I haven't been able to think of an example of a word that starts with para that means opposite or other side. You know, I think of parallel, but that doesn't necessarily mean anything. What's that? A paradox, opposite. Is that opposite? A paradox is not opposite necessarily. It's when two things are contradicting. I don't know. Para is the term they use. I haven't been able to think of one. Anyway, so this guy is 1, 2, 3, 4. So when they're in the 1, 4 position. Now this, notice I've changed the branches just to show you what happens when the branches change. This is an ethyl, right? And this is a methyl. So again, we've got to put the ethyl first, and it gets the 1. So we've got 1 dash ethyl dash 4 dash methyl benzene. So just like before, each branch gets its own number, right? And the alphabetical ethyls go first. This would be called para ethyl methyl benzene. You just string it all together, right? Para tells you the orientation, ethyl methyl tells you what two groups you're dealing with, and it's stuck to a benzene. Okay? Or P dash ethyl methyl benzene. Yep. Ethyl methyl benzene. Okay. So that's how we treat it if the benzene ring's the main guy. All right? Now sometimes the benzene ring can be a branch. Here we've got a couple practice ones. We'll do this as a practice here first before we do the branches. With this guy here, well, I'll let you draw it. I'll give you a chance to draw that up before, because I haven't given you a worksheet on this one. With this guy here, again, we've got to result in the lowest numbers, right? You start over here, you got 1, 2, 3, and 4. But if you start here, you got 1 and 2, and then 4, right? If you start over here, you got 1 and 2, and then 5. So you've got to start at this position to get 1 and 2 as your branches, and 4 as your branch. It gives you the lowest numbers. We can't use the ortho meta para because there's 3 branches. So there's no way to kind of describe just the 3 branches. So here we need, again, then alphabetical. Ethyl is going to be first. And then obviously I've got a dimethyl going. So I've got a 1 dash ethyl. And then I've got a 2 and a 4. A 2, 4 dimethyl. Again, the E comes before the M. We don't use the D to put the alphabetical. We don't use the prefix that tells you how many for alphabetical. It's the branch name letter. And then this is on a benzene. Okay? Drawing up is always easier. I always draw up in reverse because we're starting with benzene. I'll just draw the benzene shape. 1, 2, 3 triethyl. So a C2H5 and a C2H5 and a C2H5. And then a 5-propyl. 1, 2, 3, 4, 5. And propyl is C3H7, right? H7. Because you got to take that extra guy away. With that extra H on the propane to make it a propyl. All right? So again, drawing is always a little simpler. When you draw, always go in reverse. Start with the base name, and then I always go back to the front and then stick them branches back on. Okay? All right. Complex aromatic carbons. Let's just write the second bullet. Again, you can say, see page 21 of text for summary. But just write this bullet right here, this one. For people who are writing too many bullets, I'll point out which bullet I just want you to write. That's the bullet right there we want you to write. No problem. Essentially, if you've got a really long chain, and then you've got this benzene hanging off the chain, we can treat the benzene as a branch, and we call it a phenyl. And I'm not sure of the origin of this term phenyl. And let's do an example 2 of this guy with the phenyl. So again, that first branch just says it's easier to consider these big long chains with a benzene on it, treat the benzene ring as a branch. So just the second bullet is all that is needed. Okay, and we've got to name one and draw one, essentially. So for this guy here, we're counting up 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So either way, it doesn't matter. It doesn't matter which way the chain goes. So we might as well have the chain go straight through, because I could have it go up this way and get 5, or this way and get 5. I've got to have the triple bond in the main chain, and the triple bond always gets the lowest number. So for numbering it, it's 1, whoops, let me get my pen back here. It's 1, 2, 3, 4, and 5. And then my branches, that's an ethyl group. Again, don't need to write it down. And this branch here, I'm not even going to circle it, it's so big. This is a phenyl group. Ethyl will go first. So base name, 5 with a triple bond after the number 1 position. That is a 1 pent. What does it get on the end? Pentyne. That's a 1 pentyne for the triple bond. Now my branches, ethyl first, 3 ethyl, And the phenyl's also on the 3. 3 phenyl, 1 pentyne. Okay? So just treat it, if it's hanging off like a branch, as a branch, a phenyl group. Put it in alphabetically just like everything else. If you have 2 phenols, I guess you could have diphenyl. No big deal. Again, to draw, start with the back end. A 1-hexene. 1, 2, 3, 4, 5, 6. Put the double bond there. 1-hexene. And then a 4-phenyl. 1, 2, 3, 4. So stick a benzene ring off. Don't worry about the appropriate size of it. All right, so there's 6 carbons stuck on that thing and 5 hydrogens. Don't worry about it. Just put it on there as a picture. And 3-propyl. Again, that's C3H, not 8, but 7, because we had to take one off so we could stick it to it. And now load up with H's. H2, H, 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 H2, H3. There should be 2 there. All right? Same as before, except now we've got a new branch on it, named a phenyl group. Okay? So benzene ring, we either treat it as the main guy, and you can see it as the main guy. It's very obvious in my pictures whether it's a main guy or whether it's off on the side. And there's a handful of questions that you can do with naming. I think that big list of number 1, and those guys are just various ones. There might be single bonds, double bonds, triple bonds, et cetera, et cetera. Could be all kinds of mixed in. That's just a kind of a mix thing. I might have even assigned some of those already. I might have split it into 2, so you might come across some overlap there where I just split the alkanes and alkynes on their own and then separate out the aromatics.